Let us solve the motion problem from Sears and Zemansky's University Physics with Modern Physics by Friedman and Young. You can find this problem on page 101 in the 2012 edition. A snowball rolls off a barn roof that slopes downward at an angle of 40 degrees. The edge of the roof is 14.0 meters above the ground, and the snowball has a speed of 7.00 meters per second as it rolls off the roof. Ignore air resistance. A. How far from the edge of the barn does the snowball strike the ground, if it doesn't strike anything else while falling? B. Draw xt, yt, v sub xt, and v sub yt graphs for the motion in part A. C. A man 1.9 meters tall is standing 4.0 meters from the edge of the barn. Will he be hit by the snowball? The first that we need to recognize is the angle in which the ball is rolling, which is also the direction of its initial velocity. Let's magnify this so that we can be guided easily in the solution. We can see that the initial velocity is v sub o, which is 7.00 meters per second in this illustration. Its vector is already illustrated. From here, we can draw its component in the y-axis and label that as v sub oy. Then its component in the x-axis and label it as v sub ox. By inspection of the illustration and applying transversal properties, this angle is 50 degrees. Let's extract this diagram. From here we can already find the vertical velocity v sub oy, which is adjacent to the angle 50 degrees, with a hypotenuse v sub o a cosine. Then v sub ox, which is opposite to the angle 50 degrees, with a hypotenuse v sub o a sine. Then we derive the equations for each component. Then we substitute the value for the initial velocity. This gives us the vertical initial velocity is 4.50 meters per second. Negative because it is pointing downward. The horizontal initial velocity is 5.36 meters per second. We will simply call this as b sub x. Without air resistance, the horizontal velocity does not change. Now that we already described the initial conditions, we can already start with the first question. How far from the edge of the barn? This is the range of the projectile, which is the x. The range is simply the product of the horizontal velocity and the time of flight. We know how fast it is going in the x, that is 5.36 meters per second. If it takes 1 second, then the range is 5.36 meters. The time is controlled by its fall in the vertical. This gives away the idea that we can find t using the vertical components. Let's list down the variables in the vertical. Time is the unknown. The height I is 14 meters. The acceleration g in the vertical is negative 9.8 meters per second squared. And the initial velocity is v sub oy, which is negative 4.50 meters per second. Now what kinematics equation gives all these variables? If you guessed it right, well done. Now let's clear space for our solution. From this equation, let's arrive at a quadratic equation, but substituting all the known variables. We will set aside the units for now to simplify it. Y is negative 14. Initial velocity in the vertical is negative 4.50. G is negative 9.8. Then let's rearrange this in the proper quadratic form. Now it will look difficult if you are not familiar with the quadratic formula. But once you learn this in your math, this is one of the useful tools you can easily use. Now let's get the value for t. We find positive 1.29 seconds. A negative time does not make sense in this problem, so we will grey it out. The time that we get here is the time it will take the ball to fall 14 meters. This is also the time it moves in the horizontal, which leads us to the range. This gives us a range of 6.91 meters. We can already conclude the first question. The snowball will strike the ground 6.91 meters from the base of the barn. This is the first part of this tutorial. Stay tuned for part 2 for the solution for questions B and C.